Okay, for today, let's work questions 19 through 22. So let's take a look at number 19. One interesting thing, though, is that a chord is when you connect 2 points from the circle and the segment goes inside the circle. So as an example, let's say I could have, let's say that's a circle. I could find any 2 points on the circle and I connect them. The segment goes inside the circle, and that is what we call a chord. That segment is called a chord. Now, the interesting part of a chord is that when you cross them at 90 degrees with a radius or a diameter, right? Because the radius is part of the diameter. When you cross the chord in a radius at 90 degrees, the chord gets cut in half. Not the radius, the chord. So let me say that again. When you cross a radius or a diameter with a chord at 90 degrees, the chord gets cut in half. So here for question number 19, we see that SP is a radius of the circle. What is the length of the segment BR? However, I see the segment BA. If you see the segment BA is the chord, I see the radius. They're crossing at 90 degrees. So that means that the chord gets cut in half. So let me go and say this half is equal to this half. I'm asking you for BR, which is just this length, right? But I know this length right here, it is 27. So shouldn't I say that BR is also 27? Yeah, like that simple. That's how we're going to work that one. Remember, the chord gets cut in half. Now, sometimes I'm just going to ask you for part of the chord. So I could ask you for BR. I could also ask you for the whole chord. I could say, how big is the segment AB? Well, in this case, is the whole chord. That one should be the measurement of the segment AB. In this case, should be 54. But in this case, I'm only asking for BR. But I could also ask you for the whole chord. Pretty cool, huh? Pretty simple. Now, let's take a look at number 20. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. So the segment indicated is X. So it's this one. Well, shouldn't that be as big as this other one? Because I can see, I'm going to highlight in yellow. I could make a whole radius right there, right? I'm only showing you part of the radius, but a radius is crossing the chord at 90 degrees. So that means the chord gets cut in half. So my X is equal to 7 as well. Now, one thing really quick, I want to mention something here. You might be like, well, that's 7.7. I never used it. Yeah, because that was the radius. That was the radius here. Now, there's another radius here, right? This is another 7.7. And obviously, this is another radius here. This is 7.7. Sometimes I'm going to label a bunch of radii. So not just one radius, like many of them. However, sometimes, let's say I didn't give you the 7.7. So let me cross this out. Let's say I call this 15.4. And I'm going to put it right here in the center. 15.4. Well, in that case, I'm not giving you the radius. I'm giving you the diameter. When I put the measurement in the center and it's next to a diameter, I'm giving you the whole diameter. So for you to know what the radius is, we'll cut it in half. 15.4 divided by 2 is 7.7. So then you find out, oh, each radius is 7.7. We don't need it for question number 20. We don't need it here, but we will in the future. We will need it on some other questions later. Okay. So just wanted to bring that up. All right, let's take a look at number 21. ST is the diameter of the circle P and has a length of 58. RS has a length of 9. What is the length of AB? Okay, so here, let's see what we have. The whole diameter is 58. So could I say that one radius is 29? This is the half of 58. I see that S art is 9. So can I say that RP, this one is 20? Now here they're asking me, how big is the whole chord? Oh, I have no information of the chord right now, but interesting though. Let me create with blue. I know this side is 20. I'm solving for this part. I know that's half of the chord. I need the whole chord, but as long as I know half of it, I'll be okay. Let me call this side X. And then I could connect this to create a triangle because I know triangles, so I could connect that. Can I just say this other side that I just created is 29 as well? Because that's a radius. Remember, the whole diameter is 58, so radius is 50, it is 29. So the segment PB is a radius. Remember, radius is from the center to any point on the circle. And this is a 90-degree angle here, right? I see a triangle. I know two sides. I see a 90-degree triangle. I know two sides. Shouldn't I be able to solve it using Pythagorean theorem? I'm going to call this x squared plus 20 squared is equal to 29 squared. So x squared is equal to 29 squared minus 20 squared. I'm not really going to figure the squares because my numbers get too big. So I'm just going to say that x, because the way I'm going to undo the squared is by using square roots. So I'm going to say x is the square root of 29 squared minus 20 squared. Oh, let me bring my calculator for that. So I have a square root of 29 squared minus 20 squared. I see that I have, oh, cool, 21. Easy number. I don't have to deal with decimals. So my x is equal to 21. So this yellow side is 21. This other part right here that I'm also going to say is 21. How big is the whole chord? Well, 21 plus 21, right? This is 21. This is 21. So the whole thing will be 21 plus 21, better known as 42. So we sometimes will do have to use Pythagorean theorem. We learned it one time for a reason. Let's take a look at number 22. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. So we're solving for x, which is this one. I see this is 10.4, and I'm going to say this other side right here is 15.4. Because look, I see my chord got cut in half, so that's 15.4. So I'm going to say that x squared is equal to 10.4 squared plus 15.4 squared. Remember, the hypotenuse is the one that stays by itself. So the big side's the one that stays by itself. So that means that x is the square root of 10.4 squared plus 15.4 squared. Let me get my calculator for that. And we had what, 10.4 squared. So 10.4 squared plus 15.4 squared. I had to run it to nearest tenth, so one decimal place. I want to call that 18.6. Now, this question, I'm going to tell you guys, it had a different way how to do it, a little bit easier. Okay, I'm going to say it had another way how to do it a little bit easier. If we understand what we're seeing, it helps us. Now, you guys might be wondering, how can I do that? What's X? It's a radius. Okay, find another radius. Find another radius, and you know they're equal, the same thing. I could have just said that X, which is a radius, is equal to 10.4 plus 8.2, which is 18.6, right? I get the same answer. Either way I do it. So I can do it using Pythagorean theorem. Sometimes, sometimes, I'm not going to say always, because 21 is not the case. Sometimes I can just say, well, let one radius equal another radius, and that's it. We're going to solve for X that way. So X in this case is 18.6.